At the end of section 3, we left off with this chart. This is our quadrilateral chart, kind of giving us all of the information about each of our quadrilaterals. The only two we have left to do are the isosceles trapezoid and the kite. So I'll come back to that, that chart after we've gone through some of these properties. So properties of a kite. If you know that your quadrilateral, or if you know this figure is going to be a kite, you get these properties. The consecutive sides, or you can call them the next two sides, are congruent. So like this one is next to this one. These two are consecutive, they are congruent. Same thing, these two are next to each other, so they are congruent. Just because AB and AD are next to each other, they're not necessarily, these don't have to be congruent. It's just you need to have two pairs, this one and this one, and this one and this one, of consecutive congruent sides. So that would make it a kite. The cross angles are congruent. What I mean by cross angles, actually before we get to cross angles, let's go over some of the diagonals here. If I draw two diagonals, one from B to D and one from A to C, these diagonals are pretty specific kind. There's two different kinds. This longer one, oops, I want to flip that around actually. The arrow is drawing to it. The longer one there, we will call the main diagonal. It's the one that kind of cuts right in between. It starts here in between these two same sides, and it ends here between these two same sides. Okay, so it's the one that kind of cuts the whole thing exactly in half is called the main diagonal. There's another diagonal here. This one, maybe I can draw that one in red instead. Oh, that was a really thick red line. That's fine, I suppose. That one is going to be called the cross diagonal. So it's very important that we kind of distinguish between these two because they're not the same exact diagonal. They have different meanings. The cross angles, so the ones that go with the cross diagonal, are congruent. So this angle is congruent to this angle. Okay? This angle is not always the same as this angle. So it really matters which one is which. You have to say that this one goes with the cross diagonal, so the cross angles are the ones that are congruent. Now the main diagonal, the kind of skinny long orange one here, it's the perpendicular bisector of the cross diagonal. So what does that mean? Well, it means that these are perpendicular, first and foremost. It also means that this side, use red and do one, is the same as this side. So this red diagonal is cut in half. That's a really thick line. I'm going to get rid of that. That is cut in half by the longer diagonal. Now this longer diagonal isn't cut in half. Okay, this half of it, this side, is way longer than this one. But this one, the cross diagonal, is exactly cut in half by the longer one. Okay, so the main diagonal is the perpendicular bisector of the cross diagonal. The main diagonal also bisects the angles that it goes with. So this angle is the same as this angle, and this angle is the same as this angle. So this is all of the information we know from a kite. Again, cross diagonal, main diagonal. Very important to distinguish between those two. So given that information, if we start with this kite, K-I-T-E, quadrilateral kite, and we know that it's a kite, if TIE, this angle right here, is 80 degrees, and from K to T, so the cross diagonal, K to T, is 8.2 centimeters. We need to answer the following. So angle KIC, this one, K to I to C. Remember the main diagonal here, from I to E, will cut the two angles exactly in half, or bisect the angles that it goes through. So this one needs to be the same as this one, meaning KIC is 80. And down here, this one is the same as this one. So when we get there, we'll write that one in as well. The next question, KIT. So from here, 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 this larger angle. Well, if this one is 80 and this one is 80, this one would be 160. Then get rid of that piece. From C to E to T, that angle. So starting here, here, here. Okay, that one might not be so easy to get quite yet. We might need a little more information before we get that. So let's skip that one for now. We'll come back to it. K to E to T. Again, actually, let's start back on this one. C to E to T is this piece right here. I read that one wrong. C to E to T is this one. We can figure out is 28 from that piece. Now, that'll help us. K, E, T, this one down here. That one's going to be this 28 plus this 28 would be 56. And K, C, I. Here's a blue one for that. From K to C to I. Well, remember, these two diagonals will bisect or intersect each other at a right angle. So KCI is 90 degrees. This one is not an angle. This is the length CT. Well, if this whole thing from K to T is 8.2, and these are the same. They, cut in half, and it would just be half of this 8.2, so it would be 4.1. And just this piece from K to C would also be 4.1. Now the last question says if from K to I, so this piece was 12, how big is I to C? This one. Well, again, because it's a kite, it has to be the exact same, so it would be 12. 12 centimeters, 12 feet, whatever unit they're giving us. So these would be your measures for this kite. Properties of an isosceles trapezoid. If you know that your figure is an isosceles trapezoid, you get these properties. Now, first off, the only distinction between a trapezoid and an isosceles trapezoid is that the two non-parallel sides are congruent. So because it's a trapezoid, we know that these are parallel. Because it's isosceles, we know that these are congruent. So that's the only distinction. So we're kind of pretending we already knew that information for sure. So, because that is true, things that we know, the base angles are congruent. So again, it's not opposite. This one is not the same as this one up here. It's the same as this one. These two form a base. Now, if you were to flip this whole thing upside down, then these two would make a base. These and these. So it's the base angles, the ones that are right next to each other, are congruent to each other. And it's the ones that are next to each other on the same parallel line. We'll put it that way. So these are on the same parallel line. These two are on the same parallel line. Also, something else we know, the diagonals. So going from here to here, oops, don't want that line. There we go, here to here, here to here. These are congruent. They're exactly as long as each other. That doesn't mean that they cut each other in half. This length here is not the same as this length. But this whole diagonal, this piece, is just as long as this piece. So I can fit them back into their spots. They're just as long as each other. Now, because they're just as long as each other, actually, no, we'll leave it at that. That's it. That's all we know. So I'm going to go back to the table then. We'll fill everything in. Actually, this one shouldn't be filled in. For isosceles trapezoid, there's only one pair of opposite parallel sides, just like any other trapezoid. There's only one pair of opposite congruent sides. The parallel sides are not congruent. It's just the other ones that are not parallel. The opposite angles being congruent, well, it's not actually the opposite angles, it's the base angles. Other than that, the only other thing we know for sure is that the diagonals are congruent. Okay, that's everything that we can figure out, everything that we know about these, about a trapezoid. Isosceles trapezoid, sorry. About kites, none of the sides are going to be parallel, so leave that one empty. Opposite sides being congruent, it's only the sides that are next to each other, so the consecutive sides. It's not the opposite sides, it's the sides next to each other. Opposite angles are congruent, only those cross angles. Just two angles are congruent to each other. The diagonals form two congruent triangles. I'm going to go one forward here. If we look, I'm going to do this in purple, this triangle, kind of going along the edge of this diagonal here, this purple triangle is the same as this purple triangle by side, side, side. Because from B to D is the same as from B to D. So that would be two congruent triangles. So only the main diagonal cuts the figure in half and makes two congruent triangles. The other diagonal does not do that. The diagonals bisect each other. Well, again, only the main diagonal bisects the cross diagonal. So the cross diagonal is the one that gets cut in half. Diagonals are perpendicular. Yep, that is true for a kite. Diagonals are not congruent. They're not just as long as each other. And the diagonal bisects its angles. Again, only the main diagonal does that. The cross diagonal does not bisect its two angles. So we've got all of the properties then for all of our quadrilaterals. So let's continue on with some trapezoid examples here. If angle A here is 124, well, we know then that this one over here has to be 124 because base angles of an isosceles trapezoid, so these are the same, isosceles, have to be the exact same. So B is 124. Now because this is a trapezoid and these are parallel, we know that this angle and this angle are same side interior angles. And same side interior angles, when it is parallel, are supplementary. Parallel lines imply that same side interior angles are supplementary, which means that this 124 plus angle D has to equal 180. So we'd have to do 180 minus 124 to get angle D here. So D would have to be 56. And if D is 56, C is also 56. So that would be all of the angles of this isosceles trapezoid. Trapezoid midsegment. The midsegment is always the average of the parallel sides. So from here to here, whatever length that is, added on to this length from here to here, and then divided by 2 would give us this length. So if you wanted to write that out in this one, we would say AB plus DC all over 2. Okay, that's how we find an average. It's this one plus this one divided by 2 equals the length of PQ. Okay, that'll be very, very helpful. So if we know that this one plus this one divided by 2 would give us this midsegment length, to find the length of the midsegment, all we have to do is 11 plus 17 divided by 2 equals the midsegment. Well, 11 plus 17, 28 divided by 2, which equals 14. So the length of the midsegment is 14. I guess those are inches because they have the 2 tick marks there. 14 inches. Last example here. Same thing. We know that from here to here plus here to here divided by 2 equals this one. So we can say 7, because we already know how big it is, equals 10 plus 2x divided by 2. So we need to solve for x, find out how big this piece is here. Well, what we can do is multiply both sides by 2 to get rid of that divided by 2 part. So now we would have the equation 14 equals 10 plus 2x. From there, we can subtract 10. Move this piece up. That's going to leave us with 4 equals 2x. Last thing we need to do, divide by 2, divide by 2, and we're left with 2 equals x. So we have then solved for x in that case. Remember, this mid-segment is always going to be the average, or half, of these two added up. And that should do it for our last video here.